we're going to look at how to graph piecewise functions. Basically, piecewise functions we use to represent situations that need to be modeled by several different functions for different values of your domain. So here's the example. You're buying t-shirts for your team. The cost to you is dependent on the number of t-shirts you buy. If you buy 1 to 4 shirts, they are $14 each. If you buy 5 to 15 shirts, they are $12 each. If you buy 16 to 35 shirts, they are $9 each. And if you buy 36 or more, they are $6 each. So this is a situation in which our cost is completely dependent on our domain values. It's dependent on how many shirts we buy. So what we're going to do is we are going to look at how do you write a piecewise function. And we are going to use that t-shirt example. So the things that are relevant is that it is $14 each shirt if we buy 1 to 4 shirts. It was $12 if we were going to buy 5 to 15 shirts. And they were $9 if we were going to buy 16 to 35 shirts. And they were $6 if we were going to buy 36 or more. So there's kind of our relevant information. Now what we have to do is we have to think about each one of these individually. So if I only focus on this top one here, the $14 one, I know that the cost is going to be $14 per shirt. Well, I don't know how many shirts I bought, so I would have 14T. But now that is only when T is between 1 to 4. So I would have to put that domain restriction is that I'm only looking for this 14 times T if my T is between 1 and 4. The second one, since it's $12 per shirt, I would have to take 12 times T, but I only use this one if I'm buying from 5 to 15. So I would have to put a domain restriction that's from 5 to 15. The next one, if I get up into the 16 to 35 range, I'm going to pay $9 per shirt. So I would have to take $9 times T, because I don't know how many shirts I'm buying, but I'm only going to use this equation if I have 16 to 35 shirts. And my last one, $6 per shirt. And that is only if I am at 36 or above. So what I have here is a linear expression to represent each of my different scenarios. And I can't represent these all just with one linear expression because it changes. My cost per shirt changes depending on the number of shirts I have. Well, this right here is the very beginnings of your piecewise function. To finish it off, what we need to do is we need to bring a bracket around it to indicate that these are all together as a group, and then we need to put our function notation out here. So this one I would have f of t. And the reason this is f of t and not f of x is because I use t as my variable to represent t-shirts. If I had used x, then it would be f of x here. And this is our piecewise function for that scenario of the t-shirts. It's telling me if I buy from 1 to 4 t-shirts, I'm going to use this top piece only. If I buy 20 t-shirts, which would be right down here, then I have to use the 9t only. So this is what a piecewise function. It takes all those individual pieces and puts them together in one function. I know it's one function because I only have f of t, but now it's split off into these 4 different expressions for this one. Now in order to graph a piecewise function, so I've copied down our piecewise function from the t-shirt scenario, and now I'm going to graph it. Well, when I graph piecewise functions, it's graphing multiple equations with domain restrictions. So we're only going to do one little bit of it at a time. I'm going to start by doing the 14t when 1 is between t and 4. So I'm going to do a table of values. So I'm going to do an XY chart, and when t is equal to 1, I'm always going to use my endpoints for my table of values. So when I plug 1 into here, 14 times 1 is just 14. So I'm going to have to plot the point 114. Then I'm going to plug in the point 4. So when I plug 4 in here for my t, 14 times 4 gives me 56. So those are going to be the first pieces of my piecewise function. I'm going to go ahead and label my x and y axis here. Okay, now that I've got my x and my y axis labeled, I'm going to go ahead and plot my 2 points. So over here at 1, I have to go up to about 14. and at 4 I have to go up here to 56. Now those are going to be both closed circles because they have the equal to portion, and since these are actually my cut points, I can stop in between those. I've already determined what my cut points are, so I can just stop there. Now what we've done previously was we would draw the entire line and then go and do kind of like the scissors cut. Well, we don't have to do that because I've already done that with my table of values here. So for this next one, I'm going to do another table of values, but this time I'm going to be using the 12T. So my XY chart, I'm going to plug in 5, and I plug this piece into the 12T. So I would have 12T, or 12 times 5, which is going to give me back a 60, and then I'm going to do my other cut point, the 15. When I plug the 15 in there, I'm going to get back 180. So now I did both of my cut points on this one, so I can go over to my graph and I can go from 5 up to 60, and it's going to be a solid circle because it has the equal to part, and then I'm going to go over here 15 and up to 180. And then there I have my next little piece. Now remember, this doesn't go on forever because of the domain restrictions. So I only go from 5 to 15. I don't have arrows on the end of these. Okay, now we move on to the third one. So this time I'm going to be looking at only the 9T when T is between 16 and 35. So I'm going to do my XY chart, and I'm going to use my endpoints again. I'm going to use my 16, and I'm going to use my 35. When I plug 16 in there, it's 144, and when I plug 35 in there, it's 315. So then I can go over here and I can graph both of those points. Once I get those 2 points plotted, I can connect them, and again, it's not going to go beyond those points because that's my domain restriction. That's where it has to be cut off at. And then to finish this off, now I'm going to graph the last piece of this. So I'm going to do my table of values, and I am going to plug in 36. Now this one, I've only got one endpoint, so I need to pick another value that is bigger than 36. So I'm going to go ahead and just pick 39, since that's actually on my graph. When I plug 36 back in, and remember I'm plugging it only in to the 6T portion, I get 216. And when I plug 39 back in, and I'm only plugging it into the 6T, I get 234. So I can go over here and graph both of those. So at 36, I'm at 216. And then at 39, I'm at 234. Now this one is going to have an arrow on the end of it because it doesn't have this other cut point over here. So this one keeps going on forever in that direction. This is what my piecewise function is. Now notice it's got closed circles on all of them because all of them have the equal to portion of it, and the pieces with 2 endpoints are only line segments. Now a couple of things you can tell from this graph is if you were in charge of ordering these t-shirts, and let's say that you had 15 orders in, it would cost you $180. Well, if you were to order one more t-shirt, so the 16 t-shirts, it's going to end up costing you less. It's going to cost you 144 t-shirts. Now this does happen sometimes. So what you want to think about is if I've got this piecewise function and it's dealing with buying things, it might make more sense to order one more item because then it's going to drop you from the price up here down to a price down there, and it will actually be cheaper for you overall to buy that extra item or things like that. So that's just one scenario of how you can use piecewise functions. And as I look back here, I do have an error. I used T, but when I did my table of values, I put X. These should technically all be T's. It's a bad habit of mine to always use X and Y. So it should have been a TY chart, but it still has the same concept. Okay, here's a practice problem. I've given you a piecewise function here. I've given you the domain restrictions, and what I want you to do is I want you to go ahead and see what you come up with for this graph. So start by graphing each one individually and make sure you use your cutoff points. So go ahead and pause the video and see what you come up with. So for this one, I started with the x minus 4, and I wanted that one x was less than -2, so I plugged in my point -2, and then I picked another point that was less than -2 because it only had one cutoff point here. So I picked -4. Plugged both of those in only to the x minus 4 part, got my values, and I plotted them. Now notice here on the -2, it's actually an open circle because in our domain restriction right here, we don't have the equal to portion, so it has to be an open circle. This one also has the arrow on the end because it doesn't have another cut point. So it's anything that's less than -2. Well, here's my x value of -2. Less than -2 is going to the left, so I keep everything to the left, which means I have to keep the arrow on this one. Then I did the 2x part. So I used my two endpoints, -1 and 2, plugged both of those in, plotted them over here, and these were both filled in circles because they had the equal to part in their inequality here. Connected those and didn't have to do anything else with that one. And then I did the 3x minus 10 part. I used 2 as my cut point, and then it said I wanted anything bigger than 2. Well, I didn't have a second cut point here, so I just picked one because I need to get my 2 points for a line. I picked 4, plotted both of those, and this one is also going to have an arrow on it because it can be anything that's bigger than 2. So there wasn't 2 endpoints on this one, so it's going to be array. It's going to keep going on forever. Now, when you look at this one, it says it's a piecewise function. Well, you might be thinking, you know what, right here, it doesn't look like it passes that vertical line test. But what you have to realize is that it still does pass the vertical line test because that is an open circle, which means that we don't actually include that value. We get as close as we can to that value, but it's not included. So this is still a function, even though it looks like 2 points line up on top of each other, but because the one is an open circle, it still passes because that point is not included. So the piecewise functions is actually just graphing multiple linear equations with domain restrictions on one graph.